What do you think is the sum of this infinite series of fractions? At first glance, the denominators seem to have no pattern, not evenly spaced out. They're not powers of anything, they're not primes. But what's really amazing is that the sum is exactly equal to 1. Let me show you how to construct this beauty. So our first term is going to be half, because that's the largest unit fraction less than 1. So now I know that if I just added half to a half, it would just equal 1. But I'm not going to do that. I'm going to find the largest unit fraction that's less than half, and that is 1/3. So now the sum is still less than 1. The next thing I know is that if I added the unit fraction 1/6, then it will all add up to 1. So I'm not going to do that, but instead I'm going to add 1/7. That is because 1/7 is the largest unit fraction that's less than 1/6. So this means that this doesn't quite add up to 1. I'm going to repeat the same strategy. I know that if I add 1/42, then it will all add up to 1. Do that, instead we'll add 1/43, and then do the same process and find our next unit fraction to be 1/1807. So really what we're doing is adding the largest unit fraction, which is less than what's left over, every time. And this way you never quite reach 1, but you can also do this infinitely many times. Coolest thing is that these denominators are not really that hard to find, thanks to the Sylvester sequence. If you notice, 3 is just 2 plus 1. 7 is just 2 times 3 plus 1. 43 is just 2 times 3 times 7 plus 1. That means the next denominator is the product of all of the previous denominators plus 1. And that's how you get 1807. This is one of the coolest series that adds to 1. The way it's constructed is just